One more question. Let's do it. Check out this one. Look at this. We got 3x squared minus 12x plus 9. Intercepts again. Find me the y-intercept. That, of course, happens when x equals to 0. So that means, again, this is gone. This is gone. Your y-intercept is 9. So 1, 2, 3, 4, 5, 6, 7. Too much, so let's go by 2's on this one, okay? There's 2, 4, 6, 8. There's 10, so 9, the intercept would be right about there. There's our intercept at positive 9. Beautiful. Let's find the x-intercepts. And that again happens when y equals to 0. So we're going to have to factor this thing. All right, so first things first, you've got y equals to 0 equals to 3x squared minus 12x plus 9. Take out a 3. Okay, 3 is gone, leaving you an x squared minus 4x plus 3. Then PSA this. Don't forget you can let that equal to 0, so it means you can divide each side by 3, so that 3 is actually eliminated. So all you need to deal with is the x squared minus 4x plus 3. PSA, here we go. You know that that's product of 3, sum of minus 4, which is minus 3, and minus 1 works. So this is x minus 3, x minus 1 equals to 0, which means x equals to plus 3 and plus 1. So plus 3 and plus 1. So there's your critical point at 1. There's your critical point at 2. There's 3. Okay, so you're going to have this guy flying through here, kind of looking, oops. I can do a better job than that. Okay, flying through here, kind of down like this. This guy, if you want to be accurate, you're 1 over and 9, so 1 over, 2, 4, 6, 8, there's 10, there's 9 right here. This part's going to go up through here. So you're going to have some sort of bump here at exactly 2. So if you want, put the 2 back in here just to find out exactly how big of a vertex you're going to need. Okay, so put the 2 in here. 2 squared minus 12 times 2 plus 9. This I could probably do in my head. 2 squared is 4 times 3. That's going to be 12. 12 times 2 is going to be 24. And remember, minus 24 plus 9. Well, 12 minus 24 is going to give you minus 12 plus 9 is going to be, in fact, minus 3. So this guy is going to be bumped, this vertex, at 2 is going to be at minus 3. So remember, we went by 2's here. 2, 4. So it'll be right there at minus 3. So it's kind of important to find that vertex. Absolute value of it, now we're going to be at positive 3. So there's 2, there's positive 3, right about there. That's what it's going to look like. Clean it up. Put down your vertex there to be positive 3, and there's your accurate graph. Now again, we can start doing the piecewise of this. Remember our critical points here were at 1 and 3. So there's positive 1, there's positive 3. There's our critical points. The graph is normal here, the graph is normal there. So let's start writing out our piecewise. Okay, y equals to piecewise function. The graph was normal. What was the normal graph? Well, the normal graph's equation was right up there. 3x squared minus 12x plus 9. So 3x squared minus 12x plus 9, that's where the graph was normal. It was normal bigger than 3, going that way, okay? Greater than and equal to positive 3, going that way, less than and equal to 1, and then you flipped it, 3x squared minus 12x plus 9. Where was the graph flipped? The graph was flipped between 1 and 3. So when x was between 1 and 3, there you go. And again, distribute that in to give you minus 3x squared plus 12x minus 9. There's your piecewise function. There's a beautiful graph that you drew and everything else that goes along with this. I think we're getting a lot faster at this and a lot better.